electric vehicle.
Gasoline hybrid.
Guys, I like to point out that we did not go through the discharge process on this bus.
All right.
So don't get too close to the big orange wires. Right?
They know.
We better know.
So what do you have? I mean, you have basically the engine, but this generator, right?
As you can see, it's split in two. You got the engine side of the compartment, and you got the electronic side of the compartment. You got the inverters over on this side. You got the Ford Triton V10 here. And then we got the generator that's
V10 Triton
being turned by
still
the
on
engine.
power.
You can see it over on this side. Generator, 175 kilowatt generator. And it's 0 to 35 miles per hour. This vehicle will run on a capacitor power. After 35 miles per hour, the generator will take over, power up the drive motors, as well as charge your ultra capacitors up on top. You have two sets of ultra capacitors up on top, 175%.
What's the capacity?
700
volts, right?
Yeah, we're talking about
1400 volts. And the kilowatt?
1400 volts.
Basically.
It's actually,
These are capacitors. So
they're
not
capacitors.
Okay.
Batteries didn't work very well
I'm sorry, maybe my question is not. If you have a set of capacitors, just like a battery, right? You have some power stored.
Yes.
What's the kilowatt capacity of that delivery? You know.
I believe they put up to what we have on the generator.
The generator is 175 kilowatts.
Yes.
175 kilowatts.
So they store all that energy up on top.
Okay.
Up to 170.
Unlike your Prius and your smaller automotive hybrids, they have a battery pack because we stop and go constantly. We might take off and 2 blocks later we're going to be stopping again. Batteries do not charge fast enough for the transit industry. Therefore, we have to go to ultra capacitors. Ultra capacitor, fast rate of discharge, fast rate of charge. So it works a little bit better.
You have an engine, a generator, right?
Correct.
And then you have a set of electronics, telling you where the power goes or it comes from, right? And then you have what hooked up to the rear axle or differential? I mean,
From the electronics, from the generator, then we have what's called, we have 2 electric motors, and they're coupled together into what we call our gearbox. And then our combining gearbox, exactly, and that has a drive shaft going to a conventional differential. It's the same differential that you use on a diesel bus.
and this generator produces 75 kilowatts, is that right?
I think it's 175.
175 kilowatts. So the two motors, what's the rating on them? Do you know?
They run about half of that. They divide the power half of that into two, and then they both combine into that gearbox. That it's a mechanical gearbox that combines both motors into one.
Cool. Yes.
Any more questions? Up on top, in the first compartment, you'll have your, right where it says powered by clean air technology, you have your ultra capacitors. Right behind that, you'll notice it's perforated. You have your cooling system with the radiator for the engine compartment. The other side houses the cooling system for the electronics package. So it's our electronics are liquid cooled, rotated through the inverters to the drive motors and the generator.
They produce a lot of heat because of our braking resistance, our electric braking resistance.
Somebody mentioned retarder earlier on about one of the buses. That's what our resistors do here. Operator lets off the brake. This vehicle begins to slow down. Another safety feature for a transit bus. Not too many vehicles. Well, your trucks have like a Jake brake, your diesel trucks. This has a retard. Braking resistors.
Do you guys run any buses with Allison?
Yes.
With the World Allison?
Well, the World Allison transmission. However, we don't utilize their hybrid package, the Allison hybrid. I don't know. Yeah, because in order to run the Allison hybrid package, you gotta have either a CNG motor or a diesel motor. We can use a CNG powered Allison hybrid. However, that would somewhat I mean, it makes it that much more efficient, but it'll be very costly. We'll just buy a CNG bus.
In a normal Allison with a retarder.
Yeah.
Okay.
That is what we have.
That's what we run on our natural gas buses.
Any questions? You could, everybody take a look at the components there.
Yeah, that's right. Yeah, 700.
It looks like a computer. What do you currently have candidates? I think he's got it down to hours and days. Say 58. Don't quote me, I think we got 58 buses. We're going away from all, we're going away from the diesels. That's a that's a one. On a low floor buses? A low floor bus, just so you know, is you see when you walk in the front here? This is all the same level. And if you notice on that bus that's on the hoist right there, that one actually it's pretty good. The engine wasn't taking a lot of profit.
So it's a diesel motor, but then it's been modified. The heads, everything. So it's made for CNG. So the ponen las bujías, they're like hotter. They're hotter plugs. They're not
Exactly what powers this vehicle. Basically, it's a diesel engine with spark plugs in it. And pressure belts. And that's what powers up this vehicle.
So you understand, right?
CNG has been out of both alternative fuels that we employ here at the Torrance. CNG has been the best. Working flawless. Not only that, the fuel is a fraction of the cost. We're probably paying about $1.70 a gallon, equivalent gallon. That's what we got going here. Other than that, you have everything that your diesel engine would have. You have your turbocharger, your aftercooler.
Igual que el diesel, pero es CNG. El motor es igual, so no
Cummins. Yeah, Cummins got it nailed. They probably are the only CNG manufacturer right now that's working really well. You have a Korean engine out there that's built by Doosan that is in the market right now. But at one point you had Detroit Diesel and you had John Deere. However, Detroit Diesel had a lot of problems with their EGR aftercoolers, and they opted not to manufacture their engines anymore. So John Deere didn't like to work on stuff.
That is just based on the demand, based on the load. The computer will make an assessment and it'll turn them on. They put out some CFM, let me tell you. They really pull good. We were a little hesitant on at first, but it is a really good
There's so many?
It depends on the option.
Well, now with that, you can put the radio pretty much anywhere.
Wants to do, but we noticed that the hydraulic-driven fans constantly leaks. What we did, we opted to go with military-style cooling system. It works great. Yeah, we run them. Miguel's going to power them up for you, and you can see that they have.
Yeah, watch your eyes, guys.
Okay, watch your eyes, guys. Let me see if maybe we have the batteries on. Oh, yeah, the batteries on. Running. Yeah, we're not gonna run the engine.
Gonna suck us in?
I just want to run fast.
You guys familiar with two-strokes?
Yeah.
All right, let's try.
Two-stroke engine. Yeah, that's a two-stroke engine right
The
there.
holes in the sleeves,
Just like what you have in your old roof and your old.
all the sides.
Two-stroke.
Do you think this thing can make it cross-country?
That?
I'm sure it will with confidence. It ain't with confidence.
Let those fans suck you in.
No, probably. You said, I'm
All
sure.
right, here it goes.
So that's for the cooling of the electronics?
Yeah.
Yeah, watch out, guys.
Watch your olive. Military style.
Nice. Like the Abrahams.
Probably cost us about 11.
Military is not subtle, is it?
It doesn't have heating.
I feel like water coming out. You feel like water like coming out of it. Honesty, yeah. Dampness, moisture.
Well, it was water coming out. It was just clean here.
Oh, okay.
Up on top you have seven tanks.
Yeah, you can feel the breeze.
Yeah.
Come on. But that's compressed natural gas.
Water at the fin. What those fans do.